The first thing we're going to do today is show the problem of heteroscedasticity and how to do the formal test. So first, we're going to run a regression. And the y variable is going to be the price. The x variable is going to, the y variable is quantity, the x variable is price. Want the labels, going to call this hetero 1. And we look, whoops, take this down, blow this one up, we can also blow this one up. I want you to note, in particular in the first regression, the price results plot, this is not a random pattern. It's narrow at the beginning, wide at the end. Similarly down here, if we look at the plot area, all the blue dots are close to the red, then they get farther apart. That means that there's variation in the variance. Hetero, different, scedasticity, variance. So we have a problem with heteroscedasticity, probably. How do we test that? Well, we go back here, find out how many data points we had. You notice I highlighted all the data, it says 54 rows. 54, multiply that times 0.35. I forgot to type the equal sign. 18.9. So what we are going to be doing is we're going to be splitting the data into 3 sections, the beginning, the middle, and the end. And we want the beginning and the end to have approximately 18.9 data points. Well, you can't have 18.9, so it's going to be 19. First thing you have to do is sort the data. I highlighted all of that. Go to the Home tab. On the Home tab, Sort, click on the bottom, Custom Sort. Now in this case, we're sorting by price. You could have multiple, in which case you'd have to choose which one you want to sort by. You choose the variable that's an x variable that has the heteroscedasticity problem. The x variable in this case has to be price. There is no other choice. So we sort. Now we go back to the data, do data analysis, run a regression with the first half. So we want 19 data points. We're including the label, so we need 20. Chose 20. Then obviously you need the same 20 over here. Notice it says 20R. This is going to be hetero top. This is the top half. Click OK. We get the results. Now, and make sure you have 19 observations, that's what we wanted. Now we run another regression. This time it's going to be the bottom 19. Now since there's no label, you only want 19 rows. So we go here and do the bottom 19 again. We don't want labels because there are no labels in this part. And this is going to be hetero bottom. Now we have the regression results. Now to determine that we did it correctly, look at observations, got 19, go to the other one, observations is 19. Let me move this up a little bit. Observations 19, observations 19. Now to verify that there is heteroscedasticity, you have to take the ratio of the SS's. So we just copy Control C over to the other tab, Control V. Now what we have to do is we have to find the ratio. Now notice that this number is bigger than that one. Also, we expected that there was higher variations in the higher numbers. So this is going to equal that number divided by the same thing on the other. The SS total gives us 32.3 approximately. What does that mean? Well, first we have to make sure that's greater than 1. If it's less than 1, you've got the fraction upside down. Then you have to look in a table. The F table is a complicated one, but you find 19 and 19. If I remember correctly, that's approximately 2 point something. I think it's like 2.1 or something like that. Since 3.2 is greater than 2 clearly, we have a heteroscedasticity problem. What do you do about it? Well, you have to use complicated software that we don't teach in this course. So unfortunately in this case you just have to say we have a heteroscedasticity problem.